Welcome to the 2 a.m. Theory Podcast. This is where late night thoughts turn into late night conversation. Imagine humanity is the youngest civilization in the galaxy. Just picture it for a second.
Right.
We're still violent, we're still deeply divided, still struggling to figure out how to share our own planet, you know?
Oh, absolutely. We're a mess.
Yeah, and we're still learning how to control this incredibly dangerous technology we keep creating.
Mm-hmm.
So consider this kind of late-night thought for a second. What if the reason the cosmos is so eerily quiet, the reason nobody has reached out to say hello,
Right.
what if it's just because we are still considered children?
I mean, that's a profoundly humbling concept to just sit with at 2 a.m.
It really is.
To look up at the vastness of the night sky and realize that the overwhelming silence we hear might not actually be emptiness at all.
Right,
It might be a waiting room.
Or
Worse, a quarantine.
wow, yeah, quarantine. Well, welcome to the deep dive, everyone. Today we have a massive mission for you.
We really do. We're getting into the weeds today.
We are taking a huge stack of intensely dense source materials to answer one profound existential question. If the universe is mathematically supposed to be teeming with life, then where is everybody?
Exactly.
And to figure this out, we're dissecting astrophysics papers, modeling civilization progression, breaking down the methodology of these astronomical studies, looking at unexplained flashes in the 1950s sky.
Which is wild, by the way.
It's completely wild. Plus, we're analyzing declassified government radar data on unidentified anomalous phenomena and walking through the chilling mathematics of philosophical game theory.
But we need to establish our ground rules right now, up front.
Yes.
Because tonight's journey is a rigorous blend of hard empirical science and deep existential philosophy. We are exploring the concept of the quote-unquote baby civilization.
Right.
We are not here to claim definitive facts about aliens or endorse any specific geopolitical narrative. That is especially true when we get to the declassified government reports later on.
Yeah, we have to be super clear about that. We are impartially analyzing the raw data and the telemetry described in those reports.
Exactly. Completely divorced from any political posturing, we're looking at humanity's place in the dark, examining the anomalies and the theories that the brightest scientific minds use to make sense of our isolation.
So let's start by grasping the terrifying scale of the nursery we live in. Because, you can't understand the silence until you understand the size of the room.
That's a great way to put it.
The observable universe contains somewhere around 2 trillion galaxies. 2 trillion, and inside every single one of those galaxies are billions, sometimes trillions, of stars.
It's almost absurd.
Yeah, the numbers completely break the human capacity for visualization.
They really do, which is why astrophysicists rely on mathematics to even frame the problem. The foundation of this entire discussion begins with the Drake equation.
Right, from Frank Drake.
Yes. Formulated by radio astronomer Frank Drake back in 1961 at the Green Bank Observatory. It is basically a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in our own Milky Way galaxy.
But it's not like an equation you solve for a definitive number, right?
Exactly. It isn't an equation where you get a hard integer at the end. It's more of a framework for organizing our ignorance.
I love that phrase, organizing our ignorance. I was looking at the actual variables in the equation earlier, and what strikes me is how it acts like a funnel.
Mm-hmm. Yes.
It starts with hard astrophysics and ends with, sociology. It multiplies the average rate of star formation by the fraction of those stars that have planets, by the number of planets that can actually support life.
And then it moves into biology and sociology, right?
Right.
It multiplies that result by the fraction of those planets where life actually develops, the fraction where that life evolved intelligence, the fraction where that intelligent life develops technology capable of interstellar communication.
Which is a huge leap.
Huge leap. And finally, it multiplies all of that by L, and L is the length of time such civilizations release detectable signals into space.
And here is the core tension for you listening. Even when astrophysicists plug incredibly conservative, pessimistic numbers into that equation, the result suggests the Milky Way should be loud.
It should be deafening.
Right. It should be absolutely humming with the radio traffic of thousands of ancient civilizations.
Which leads us directly to the physicist Enrico Fermi. During a casual lunch at Los Alamos in 1950, he basically synthesized this contradiction into what we now call the Fermi paradox.
Just over lunch.
Just over lunch. He looked at the vast probability of life and simply asked, where is everybody?
Because despite systematic, decades-long searches, there is no reproducible, reliable evidence of transmission.
None at all.
For instance, the SETI Institute has spent years scanning what they call the water hole, specifically the 21-centimeter hydrogen line at a frequency of 1420 megahertz.
Yeah.
And I really want to pause on that because the physics of why we listen there is fascinating. Hydrogen is the most abundant element in the universe, right?
Correct.
And when the electron in a neutral hydrogen atom flips its spin, it emits a photon with a wavelength of exactly 21 centimeters.
And that is a crucial detail, because radio astronomers chose that specific frequency for a very good reason. It penetrates the dust clouds of the interstellar medium exceptionally well.
Right, so the signal doesn't get blocked.
Exactly. Furthermore, it's a frequency that literally any radio-capable civilization in the cosmos would inherently know about.
Because it's physics.
Yes, it's written into the fundamental quantum mechanics of the universe.
Yeah.
It serves as a sort of universal hailing frequency.
Like a cosmic channel one.
Basically. Yet, when we tune our massive radio telescopes to that universal channel, we hear nothing but the cosmic microwave background radiation and the natural hum of pulsars.
Just static.
It is a profound, eerie silence.
But applying a bit of skepticism to our own methods here, isn't it wildly anthropocentric to assume an ancient, godlike alien race would even communicate using radio waves?
Oh, absolutely.
I mean, radio is essentially a 19th century human invention. If a civilization is 1,000,000 years older than us, assuming they use radio feels like a toddler sitting in a sandbox, holding a telegraph machine, and wondering why nobody is sending them a text message.
That's a perfect analogy.
Right. What if they are broadcasting across the galaxy by manipulating the fabric of space-time itself using gravitational waves, or utilizing quantum entanglement for instantaneous communication across light years?
And that critique cuts to the absolute heart of modern astrobiology. We suffer from a severe technological bias.
Right. We don't know what we don't know.
We can only search for the signatures we currently understand. And this brings in the physical reality of this space we are dealing with. Space is so unimaginably large that any communication bound by the speed of light introduces a massive civilization-ending delay.
Civilization ending, wow.
Yes, because if a civilization is 10,000 light years away, any message they send takes 10,000 years to reach us. The window of time that a technological civilization exists might be incredibly brief.
Right, they might be long gone by the time the signal hits our dish.
Exactly. Two highly advanced civilizations might rise and fall in the same exact galactic arm, but simply never overlap in time.
So if we want to know if we are even advanced enough to be noticed or to understand the signals around us, we need a ruler.
A metric.
Yeah, a way to measure our civilization's technological maturity against the potential rest of the cosmos. And that brings us to the Kardashev scale.
Yes, a classic.
This was proposed in 1964 by a Soviet astronomer named Nikolai Kardashev. He needed a universal metric, and he brilliantly chose the one thing every civilization, regardless of its biology, must obey.
Thermodynamics.
Exactly. Kardashev realized that to do work, to compute data, to alter a planetary environment, you need energy. So he classified hypothetical civilizations into 3 distinct types based on their raw energy consumption.
Okay, let's break these down. So a type I civilization, a planetary civilization, can harness all the available energy reaching its home planet from its parent star.
All of it.
All of it. For Earth, that equates to roughly 10 to the 16th power watts of energy. We are talking about absolute mastery of planetary resources, total utilization of solar, geothermal, and wind energy without disrupting the biosphere.
10 to the 16th watts, which is insane, but the jump to the next tier is what really breaks the mind.
It really does. A Type 2 civilization is a stellar civilization. They have outgrown the energy budget of their planet and can consume their star's total energy output directly.
This is where Dyson spheres come in.
Exactly. It's frequently discussed in the context of a Dyson sphere, a concept proposed by physicist Freeman Dyson in 1960. It involves constructing a massive megastructure, or like a dense swarm of solar collectors, completely enclosing a star to capture its total radiation.
That is just terrifying to imagine.
It brings the power level up to 10 to the 26 power watts.
A lead of 10 billion times more power.
Yeah. And then there is the Type 3 civilization, the galactic civilization.
Inaudible.
Pretty much. They are capable of capturing the energy of an entire galaxy, harnessing billions of stars, and the rotational energy of supermassive black holes. They operate at roughly 10 to the 36th power watts.
So listening to those three tiers, planetary, stellar, galactic, you might instinctively think humanity is at least a type I.
You'd hope so.
Yeah, I mean, we split the atom, we mapped the human genome, we sent rovers to Mars, but the math tells a very different, very humbling story.
It really does.
In 1973, Carl Sagan realized Kardashev's categories were too broad to be useful for classifying early-stage civilizations like ours, so he created a finer, continuous scale using logarithmic interpolation.
Right, because Sagan understood that energy consumption in the universe scales exponentially, so a simple linear scale wouldn't work.
Yeah.
He formulated an equation. K equals the base 10 logarithm of power consumption in watts minus 6, all divided by 10.
It's elegant.
It is. It allows us to pinpoint exactly where we are on the board.
And based on the energy data we have from recent years, our global energy consumption was around 595 exajoules in 2021, which translates to roughly 18.87 terawatts. If you plug 18.87 terawatts into Sagan's logarithmic formula, humanity is a mere type 0.73.
Barely on the board.
We aren't even a type I. We are a fraction of a planetary civilization.
And Sagan coined a specific term for this phase. He called it technological adolescence.
Adolescence. Ouch.
Yeah, it is a highly volatile, inherently unstable stage of development. We possess enough technological capability to destroy our planetary biosphere through nuclear winter, anthropogenic climate collapse, or, engineered pathogens.
Right.
But we do not yet possess the technological maturity, the planetary control, or the social cohesion to actually save ourselves or evacuate our population if the biosphere fails.
We are essentially the teenagers of the cosmos holding a loaded weapon, arguing over who gets to sit in the front seat of the car.
That's entirely accurate.
But I found a fascinating modern expansion on this in our sources. Because measuring a civilization just by raw thermodynamics feels like a blunt instrument.
He is a bit simplistic, yeah.
A paper by Jonathan Zhang and colleagues introduces a modern metric called the Civilization Development Index, or CDI.
The CDI is a profound, multidimensional approach. Zhang's team argues that to reach Type I status, a civilization needs to pass critical milestones beyond just burning more fuel.
Okay, like what?
First, it requires an evolution in information processing. Humanity is currently generating zettabytes of data, but the paper discusses moving toward a concept called the sentience quotient, specifically achieving a level of communality.
See, I read that and immediately thought of a dystopian hive mind, like the Borg.
Oh, sure.
But it's actually much more nuanced than that. How does the paper define this communality?
It definitely doesn't mean erasing individuality. The sentience quotient is a measure of the efficiency of an intelligence, essentially the maximum bits of data processed per second per kilogram of mass. Communality refers to a level of instantaneous, globally connected consciousness and data sharing that fundamentally alters how a species operates. It's the seamless integration of biological and artificial intelligence on a planetary scale, eliminating the friction of miscommunication that causes wars.
Okay, that makes sense. And the second pillar of the CDI is construction mass and population dynamics. Because you can't just pave over your planet's surface to build server farms and solar panels.
Exactly.
A Type I civilization must navigate the demographic transition and figure out how to manage its carrying capacity sustainably. It's about ecological equilibrium.
Precisely. And Zhang's paper actually runs the mathematical projections on this. Taking our current rate of energy growth and technological development, they modeled our trajectory.
So what's the ETA?
Assuming we navigate the massive bottlenecks of self-destruction, their models suggest humanity might finally reach Type I status around the year 2271.
Just a little over 2 centuries from now. And to reach Type II, where we start taking apart planets to build a Dyson swarm around the sun, that wouldn't happen until somewhere between the years 3200 and 3500.
A long way off.
So, to bring this back to the baby civilization concept, for you listening at home, we are a toddler who just figured out how to strike a match. Splitting the atom was our first little spark. And because we made fire, we suddenly think we are ready to build a fusion reactor and join the adults at the galactic table.
And that analogy raises an incredibly chilling question.
Yeah.
When a toddler strikes a match in a dark forest, it emits a sudden, sharp burst of light. It draws attention.
Oh, wow.
What if humanity's first volatile steps into advanced technology, our first atmospheric atomic weapons tests, accidentally sent a massive visible flare up into the dark?
This is where the source material takes a hard left turn from theoretical astrophysics into historical empirical observation. And honestly, looking at the methodology of this study gave me chills.
It's a very rigorous paper.
Let's dig into the POSSI transient study, published recently in the peer-reviewed journal Scientific Reports by researchers Stephen Vroll and Beatrice Villarroel.
The foundation of their study rests on the Palomar Observatory Sky Survey, or POSSI. This was a monumental astronomical survey conducted between 1949 and 1957 using the 48-inch Samuel Oschin telescope in California.
The timeline is the most critical piece of context here, 1949 to 1957.
Right.
This survey was conducted before the Soviet Union launched Sputnik. This was before humanity had placed a single artificial satellite into orbit.
There was nothing up there.
Exactly. There was no human space debris, no Starlink constellations reflecting sunlight, no high-altitude weather balloons cluttering the upper atmosphere. Technologically speaking, the orbital sky was completely pristine.
Yet, when modern researchers digitized and analyzed the original glass photographic plates from that 1950 survey, they found glaring anomalies.
What kind of anomalies?
They discovered what astrophysicists call short-lived star-like transients. These were bright, intense flashes of light that appeared clearly on the photographic emulsion, which had an exposure time of about 50 minutes. And then they just vanished.
Just gone.
They were absent in images taken of the exact same coordinates just days prior, and they never appeared in any subsequent surveys of that patch of sky.
I know the immediate reaction from anyone scientifically minded is to assume these are artifacts. You know, a scratch on the glass plate, a smudge of chemical emulsion, or maybe a camera glitch.
Which is a responsible first assumption.
Right, but the researchers spent exhaustive effort ruling out prosaic explanations using optical physics.
They really did. They analyzed the point spread functions, or PSFs, of these flashes. When a telescope captures light from a genuine distant point source in space, the light diffracts through the circular aperture of the lens, creating a specific mathematical pattern on the plate, an airy disk.
Okay, an airy disk.
Yes. And dust, scratches, or chemical defects on the glass do not possess this specific diffraction pattern. The transients exhibited perfect stellar PSFs.
Oh, wow.
They behaved exactly like genuine sources of light coming through the vacuum of space and through the optics of the telescope. Furthermore, they weren't shooting stars or fragmenting near-Earth asteroids because they didn't leave trails or streaks over the 50-minute exposure.
Right, they're just dots.
They were stationary point sources that flashed intensely and then disappeared.
So we have mathematically verified unexplained flashes of light in high orbit before humanity put anything into high orbit. That alone is a huge mystery.
It is.
But the statistics they layered over this data are staggering. The researchers took the specific dates and times these transients were captured and cross-referenced them with another timeline from that exact era. The timeline of above-ground nuclear weapons testing.
Yes. Between 1949 and 1957, the United States, the Soviet Union, and Great Britain were in the early, highly volatile stages of the Cold War, conducting 124 above-ground nuclear tests.
And the correlation.
The statistical correlation the researchers discovered is genuinely unsettling. They found that these mysterious transient flashes in the sky were 45% more likely to occur on dates falling within a one-day window of a nuclear detonation.
A 45% increase.
Yes.
I mean, in statistical modeling, that is not a minor deviation or background noise. That is a massive flashing correlation.
It's highly significant.
And they went further. They also cross-referenced the dates of the transients with a historical database of civilian and military witness reports of unidentified anomalous phenomena known as the UFOCAT database.
UFOCAT is one of the most comprehensive, rigorously maintained catalogs of historical UAP sightings, originating from the data collected by the U.S. Air Force's Condon Committee in the late 1960s.
And what did they find there?
The researchers found that for every additional independent verified UAP sighting reported globally on a given date, there was an 8.5% increase in the number of these transient flashes observed by the Palomar telescope.
Let me just synthesize what that data is implying for you. On the specific days, humanity decides to detonate atmospheric nuclear weapons, military and civilian personnel reports seeing more UAPs in the sky, and simultaneously, the most powerful telescope on Earth captures unexplained flashes of light in high orbit.
That's the data.
What is the physical mechanism here? How does the paper explain this?
Well, the researchers are careful to outline a few hypotheses. The first is a highly exotic, unrecognized atmospheric effect caused by the nuclear fallout itself.
Like a natural reaction.
Exactly. When you detonate a nuclear weapon, it releases a massive wave of high-energy particles. If these particles interact with the upper layers of the ionosphere, they could potentially cause a localized visible glow known as Cherenkov radiation.
Cherenkov radiation, like
Yeah.
in a reactor.
Yes. Cherenkov radiation occurs when a charged particle travels through a dielectric medium like the atmosphere, faster than the phase velocity of light in that specific medium. It produces a faint blue glow, similar to what you see in the water of a nuclear reactor core. The Palomar telescope might be capturing a bizarre, uncatalogued atmospheric reaction to the radiation spike.
Okay, so that is the hard science, prosaic explanation, but I need to push back using the exact context of our baby civilization premise.
Please do.
Let's assume the alternative hypothesis. Let's assume these are probes from an advanced intelligence. If I'm a Type 2 or Type 3 civilization on the Kardashev scale, commanding the power of billions of suns, engineering the thermodynamics of entire solar systems, why would I possibly care that a group of hairless apes on a tiny waterlogged rock managed to trigger a primitive fission reaction?
Right, it's a valid question.
A nuclear bomb is energetically less than a firecracker compared to the natural fusion happening inside a star. Why bother watching?
It is a question of thermodynamics versus artificiality. You are correct that to a Type 3 civilization, a 15-megaton nuclear blast is energetically irrelevant. But it is entirely significant as an artificial signature.
Ah, artificial.
Right. Stars perform nuclear fusion naturally. It is the fundamental engine of the universe. However, splitting heavy atomic nuclei fission in a concentrated, weaponized burst on the surface of a delicate biosphere. That does not happen naturally.
No, it hasn't.
It requires intent, engineering, and metallurgy.
It's the ultimate artificial thermodynamic spike.
Exactly. It acts as a cosmic alarm bell. It signals to any automated surveillance network or observer in the vicinity that the baby civilization has unlocked the fundamental binding energy of the universe. They have discovered how to alter matter at the atomic level. They have found the loaded gun.
So it's a milestone.
Yes. Therefore, the more startling hypothesis the paper cautiously entertains is that these transient flashes might be highly reflective, artificial objects in high Earth orbit, perhaps automated probes that were already dormant in our solar system, reacting to, repositioning, or transmitting data about our sudden, violent leap into the atomic age.
And if that alarm bell rang in 1945, if automated probes saw the flash and sent a signal back to the observers, did anyone come down closer to the surface to investigate?
Well, that's the multi-million-dollar question.
This brings us directly into the modern era of unidentified anomalous phenomena science. And I want to reiterate our earlier disclaimer for you. We are looking at the raw, declassified radar and telemetry data acknowledged by the Pentagon, separating the actual physics from any government public relations narrative.
That's essential. Because for over 70 years, the topic of UFOs was heavily stigmatized, relegated to the fringes of science fiction and conspiracy. But that paradigm shifted violently in 2017 when the public learned of covert, deeply funded Pentagon programs, specifically ATIP and AWSA.
The Advanced Aerospace Weapons System Application Program.
Yes.
And these weren't fringe groups, right?
Not at all. AAWSAPE was managed by veteran defense intelligence analysts and scientists, funded with $22 million specifically to investigate these encounters using military-grade sensor platforms. They produced over 100 deep-dive research papers on the physics of the phenomenon.
And the cornerstone of their investigation is detailed in a comprehensive paper from Science Direct, authored by Kevin Knuth and a team of physicists, regarding the 2004 Nimitz encounter.
The Nimitz event is the gold standard for UAP data because it involves multiple, independent, corroborating sensor systems. It wasn't just human eyewitness testimony from highly trained Navy fighter pilots.
It was hard data.
Exactly. The objects described as smooth, white, oblong shapes lacking wings or exhaust, resembling a tic-tac mint, were tracked by the USS Princeton's ANSPY-1 radar system, which is one of the most sophisticated phased array radars on the planet.
I read the breakdown of the flight kinematics from the AAWSA scientists' 140-page report. The radar data tracked these objects dropping from 80,000 feet, which is basically the edge of space down to sea level in a matter of seconds.
Seconds.
The physicists calculated the acceleration required to perform that maneuver. The object was pulling hundreds of g-forces. To put that in perspective, a human pilot blacks out and dies around 9 or 10 Gs.
And the craft itself.
Our most advanced titanium airframes would literally shred into confetti under that kind of thermodynamic stress. Furthermore, they accomplished this without creating a sonic boom and without any visible thermal exhaust plume on the fighter jet's forward-looking infrared, or FLIR, targeting pods.
Which completely defies our current understanding of aerodynamics and propulsion. It suggests they are not pushing mass out the back to move forward like a jet engine.
And how are they moving?
Some physicists theorize they might be utilizing space-time metric engineering.
Metric engineering.
Yes, essentially manipulating gravity to encapsulate the craft in a localized bubble of space-time, similar to the theoretical Alcubierre warp drive. This would explain the lack of a sonic boom, as the craft isn't actually moving through the air, but rather the space around the craft is moving.
And this leads to the most mind-bending detail from the Science Direct paper. Note the recent shift in terminology by the U.S. Congress. They expanded the acronym UAP from Unidentified Aerial Phenomena to Unidentified Aerospace Undersea Phenomena.
The undersea designation is crucial. It acknowledges their transmedium capabilities. The sensor data shows these objects don't just operate with impunity in restricted airspace, they seamlessly dive into the oceans and travel underwater at impossible speeds, completely unaffected by the transition from air to water.
The physics of that are baffling. Water is roughly 784 times denser than air. Hitting the ocean surface at Mach speed should be like hitting a brick wall.
It would vaporize a normal craft.
Right, unless they are generating a supercavitation bubble, or again, utilizing a space-time envelope, the sheer kinetic impact should destroy them. But they just slip beneath the surface, and this connects right back to the nuclear alarm bell, because these transmedium objects don't just wander randomly. There is a deeply unsettling historical pattern.
We have to look at the work of researcher Robert Hastings. He has spent over 5 decades interviewing more than 150 military personnel, including launch control officers.
And the pattern.
The pattern is irrefutable. UAPs have specifically repeatedly loitered around our nuclear infrastructure. They appear over atomic testing sites, uranium enrichment facilities, and nuclear-powered aircraft carriers.
The most famous case being Malmstrom Air Force Base in 1967, known as the Echo Flight Incident.
Yes.
An object hovered over the missile silos, and simultaneously, 10 fully operational Minuteman intercontinental ballistic missiles inexplicably dropped offline, entering a no-go state. The guidance and control systems were somehow remotely disabled.
Which forces a massive philosophical deduction.
Okay, lay it out.
If these objects are here, possessing technology capable of shutting down our most advanced strategic weapons, and they have been observing us for decades without launching a kinetic attack, why haven't they made formal contact? Why hover in the shadows, analyzing our silos?
This brings astrobiologists to the zoo hypothesis.
Formulated by astronomer John Ball in 1973, the zoo hypothesis perfectly bridges the gap between the Fermi paradox and the UAP data. It suggests that highly advanced civilizations are entirely aware of our existence, but they intentionally avoid direct interference.
They are just watching.
They are observing us, allowing us to evolve naturally.
It is the ultimate expression of the prime directive from science fiction. The logic is grounded in sociology. If a Type 3 godlike species suddenly landed a mile-wide ship in the center of a major city and revealed the secrets of the universe, the resulting cultural shock would completely shatter human civilization.
Absolutely.
It would destroy our religious frameworks, collapse our financial markets, and completely short-circuit our natural technological evolution.
Think about our own methods of biological observation. When human anthropologists or biologists want to study uncontacted tribes deep in the Amazon, or observe a family of silverback gorillas, they go to incredible lengths to hide themselves.
Right. They set up blinds, use silent drones, wear camouflage.
You do not walk out of the jungle and hand a gorilla a smartphone.
Exactly. Not only would it confuse the animal, it completely contaminates the natural environment you are trying to study. You wouldn't be studying a wild gorilla anymore. You'd be studying a gorilla interacting with human technology.
So the observers need humanity to act naturally, to gather accurate data on our sociological development. But there is a much darker, much more existential edge to the zoo hypothesis.
The dark edge.
Yes. If they're watching us like animals in a preserve, what specific behavior are they waiting to see? What if they aren't just taking passive notes on our culture?
What if they are watching our nuclear silos so closely because they know we are rapidly approaching a threshold that almost no civilization survives?
That thought moves us out of sociology and straight into the terrifying concept of the Great Filter.
The Great Filter.
Introduced by economist and futurist Robin Hanson in 1998, the Great Filter is a probabilistic argument attempting to resolve the Fermi paradox. Hanson laid out an evolutionary timeline consisting of 9 crucial steps that life must pass to evolve from inanimate matter to a star-spanning Type 3 civilization.
What are the steps?
These steps include the genesis of replicating molecules, the jump to single-celled life, The incredibly complex evolution of eukaryotic cells, the development of sexual reproduction, multicellularity, encephalization, or, big brains, and the development of tools.
Hansen's argument is that somewhere along that path there exists a bottleneck, a filter, an evolutionary barrier so incredibly difficult to pass that the vast majority of life in the universe simply dies trying.
And so the reason the universe looks empty is because almost everyone fails the test.
The existential question for humanity then is simple. Where is the filter located? Is it behind us or is it ahead of us?
If you look at the news on any given day, it feels like the filter is staring us right in the face.
It really does.
Let's catalog the potential filters humanity is accelerating toward right now. We've spent an hour discussing the first one, global nuclear annihilation. But beyond that, we face the slow, grinding threat of anthropogenic climate collapse, the rapid depletion of natural resources, the terrifying democratization of synthetic biology, where a small group could engineer a highly lethal pathogen.
And the ultimate wildcard, the development of unaligned artificial superintelligence.
Right.
Any single one of those bottlenecks could be the great filter that wipes us off the board before we ever reach type I status on the Kardashev scale.
This is exactly why researcher Zoltan Galantai proposed a massive revision to how we measure success. He argues that Kardashev's focus on energy consumption is a flawed metric.
It misses the point of survival.
Right. Generating 100 terawatts of power means nothing if you blow yourself up the next day. Galantai proposes a resilience scale. He measures a civilization strictly by its capacity to survive disasters.
I find Galantai's metric far more grounded in reality. How does his scale work?
On Galantai's scale, a Type I civilization has the technological, sociological, and infrastructural capacity to survive a localized or regional natural disaster without a systemic collapse.
Okay, localized.
A Type II civilization has the resilience to survive a continental disaster. And a Type III civilization possesses the robustness to survive a global, planetary-scale catastrophe like an asteroid impact, the eruption of a supervolcano, or a massive manufactured biological threat.
If we evaluate humanity honestly using Galantai's metric, it's terrifying. A localized, relatively mild viral pandemic completely fractured the global supply chain, caused massive economic instability, and triggered widespread social division.
We failed the stress tests.
We are struggling to prove we are even a Type I on the resilience scale. Our systems are incredibly fragile, optimized for efficiency and profit rather than robustness and survival.
We are a fragile species playing with civilization-ending tools. But wait, let's inject a sliver of optimism into the 2 a.m. dread. Looking back at Hansen's 9 steps, isn't it statistically possible we already passed the great filter?
It is possible, yes.
What if the genuinely impossible leap wasn't splitting the atom, but the leap from prokaryotic to eukaryotic life billions of years ago? Evolutionary biologists note that eukaryotes only evolved once in Earth's history.
Right. That was a massive bottleneck.
Maybe that was the filter. Maybe the galaxy is silent simply because we are the rare, wildly lucky anomaly that made it through the hardest part of the maze.
That is the optimistic resolution to the Fermi paradox, and it is scientifically plausible. We might be the first. We might be the elder race.
But
However, the pessimistic view requires a grim thought experiment. Astrobiologists often say that the absolute worst possible news humanity could ever receive would be discovering the ruins of an extinct advanced civilization on Mars, or finding fossilized complex life under the ice of Jupiter's moon, Europa.
I remember reading that concept, and it took me a minute to grasp the logic. Why is finding alien ruins the worst possible news?
Because it alters the probability curve. If complex life was common enough to evolve independently twice in the exact same solar system, and both times it reached a technological state and then perished, it proves the great filter is not the jump to multicellular life. The biological steps are easy. It implies the great filter is the technology itself.
Wow.
It means the filter is firmly ahead of us, waiting in our immediate future, and statistically, we're almost certainly doomed to hit the same wall they did.
That is an incredibly dark realization. But looking through the final source material, there is a theory that makes the great filter look like child's play.
Oh, yes.
What if civilizations do survive the filter? What if they manage to navigate nuclear weapons, AI, and climate collapse, and they reach Type II or Type III status, but they learn a terrifying, universally true lesson along the way?
The lesson of silence.
What if the universe isn't empty at all? It's just holding its breath.
We have arrived at the dark forest theory.
Let's shift the mood, because this is where the deep dive enters the realm of pure mathematical paranoia. The dark forest hypothesis was brought into the mainstream by the brilliant science fiction author Lou Sixon in his novel The Dark Forest. But while it was popularized in fiction, the underlying mechanics are based entirely on real-world game theory, specifically the mathematics of sequential, incomplete information games.
It is a flawless, deeply disturbing application of cosmic sociology. Lou Sixon builds the theory upon two fundamental axioms that govern life in the universe.
And those are?
Axiom 1. Survival is the primary overriding need of every civilization. Axiom 2. Civilizations continuously expand and grow over time, but the total matter and resources in the universe remain finite and constant.
So the board is set. Every single player wants to survive, and every player needs to consume resources that are fundamentally limited. It is a cosmic recipe for conflict.
Inherently.
But the real horror of the Dark Forest doesn't come from a desire for conquest. It comes from the mechanics of communication across the void. The theory relies on a concept called the chain of suspicion.
The chain of suspicion is a psychological death spiral. Let's walk through the agonizing logic of a sequential, incomplete information game. Imagine humanity detects a faint radio signal from another civilization 20 light years away.
Okay, we get a ping.
We have two choices: reply and make contact, or stay silent. If we make contact, we have absolutely no way of knowing if their culture is benevolent or hostile.
Okay, but let's assume the best. Let's assume we somehow decode their message and we realize they are a peaceful, philosophical species.
It doesn't matter if they are peaceful, even if they are fundamentally benevolent, because of the vast distances and the impossibility of instantaneous communication. They have no way of knowing for sure that we are peaceful.
Oh, because of the delay.
Yes. They might assume our message is a trap.
Yeah.
And even if we know they are friendly and they know we are friendly, how do we know that they know that we know they are friendly?
It's an infinite loop.
The chain of paranoia loops back on itself infinitely. In game theory, when you cannot verify the internal state of the other player, you can never truly trust their intentions.
And then the theory drops the wild card onto the table, the technological explosion.
This is the catalyst for the violence. Progress is not linear, it is exponential. Let's say a highly advanced galactic civilization detects Earth's nuclear flashes today. They see we are primitive, a mere type 0.73. We pose zero military threat to their Dyson spheres.
Right, we're ants.
But they understand the nature of exponential growth. They know that in just a few centuries, which is a microscopic blink of an eye on a cosmic timescale, we could undergo a sudden technological explosion, master new physics, and suddenly become a lethal, peer-level threat to their survival.
So pure mathematics takes over. Because of the limited resources of the universe, the infinite, unresolvable paranoia of the chain of suspicion, and the ever-present threat of exponential technological growth, the only logical, rational outcome.
The Nash equilibrium.
The Nash equilibrium in this game is a preemptive strike.
The universe is a dark forest. Every advanced civilization is an armed hunter, stalking silently through the trees like a ghost, terrified of making a sound. If you scream, if you broadcast your location via radio waves, or light up the sky with an artificial nuclear thermodynamic signature, you reveal your exact coordinates to the forest.
You give away your position.
And because the hunters cannot risk you eventually evolving into a threat, the only safe, mathematically sound move is to eliminate you immediately, often using untraceable methods like relativistic kill vehicles, traveling at a fraction of the speed of light. The universe is quiet because everyone who is loud is already dead.
Anyone who screams gets eliminated. When you framed it like that, it makes you look at our early efforts, like the Arecibo message broadcasting a map of our solar system, our DNA structure, and human biology into the void in a very different, highly alarming light.
We handed them a map.
We essentially stood up in the dark forest and yelled, "Here we are."
We did. But as rigorous analysts, we must examine the critiques of this theory because it assumes a highly paranoid zero-sum game. The primary argument against the dark forest is the scale of the universe itself. Space is incomprehensibly vast. While resources are technically finite, they are practically limitless for a civilization capable of harnessing stellar energy or mining asteroid belts.
So they don't need our planet.
Right. The energy required to launch an interstellar preemptive strike across thousands of light years might far exceed the energy required to simply move to a new star system.
Plus, escaping is relatively easy in the vacuum of space. You don't have to fight a war over a planet. You can just migrate. And if we look at our own history on Earth, the evolution of cooperation often wins out over blind aggression. We build alliances. You don't see packs of wolves constantly trying to wipe out bears in the forest. The energetic cost and the risk of injury in the conflict are too high. A Federation-style mutual defense pact might be a much more common, stable mathematical equilibrium than everyone hiding in the bushes with a sniper rifle.
That's a good point.
Communication, diplomacy, and trade are often far cheaper and safer than launching a blind interstellar attack.
That is a highly compelling sociological counterargument. However, if we merge these concepts, the dark forest and the UAP observation data, perhaps the hunters do exist, but they do not target everyone indiscriminately.
Oh, like they have criteria.
Perhaps they only target those who exhibit inherently violent tendencies. If an advanced automated observer detects a species that solves its internal planetary disputes by dropping fission weapons on its own biosphere, they might mathematically mark that species as a future threat to the galactic community.
That makes a terrifying kind of sense.
This could be exactly why we are isolated. Not because everyone is hiding from everyone else, but because humanity is currently locked in a strict cosmic quarantine until we prove we can safely wield the fire we've discovered.
We are in a galactic timeout. They are waiting to see if we grow up or blow up.
Essentially, yes. It is an observation period.
Okay, let's take a deep breath and zoom out for you, because we have covered a staggering amount of conceptual ground tonight. We started with the sheer probability and the deafening silence of the Drake equation. We measured ourselves using thermodynamics on the Kardashev scale and realized we are barely a type 0.73, struggling to manage our own planetary carrying capacity. We looked at empirical optical data from the 1950s Palomar survey showing unexplained transients correlating mathematically with our first volatile nuclear tests. We traced declassified Pentagon radar data tracking transmedium objects hovering over our nuclear infrastructure. We faced the existential bottleneck of the Great Filter and walked through the chilling, paranoid mathematics of the dark forest.
It paints a vivid, albeit unsettling picture. We are a deeply young species, a baby civilization, flashing artificial nuclear lights in the dark, desperately wondering if anyone is looking back.
Yes.
We are advancing technologically at an astonishing exponential rate, generating zettabytes of information and preparing to leave our home planet.
But emotionally, sociologically, and politically, we are still incredibly primitive. We still operate on zero-sum tribalism.
So, what does this all mean for us? Stripping away the math and the astrophysics, what is the core takeaway from this 2 a.m. deep dive? The overarching takeaway is a question of maturity. If there are advanced observers out there, whether they are silently waiting in the dark forest or carefully observing us from a galactic zoo first contact, might not be a question of raw intelligence.
Because they already know we're smart.
Exactly. They already know we are smart enough to build machines and split atoms. The real test is maturity. The observers might simply be waiting for us to unite as a singular planetary species.
Right.
They're waiting for us to move past our self-destructive tendencies and achieve true communality before they invite us to the galactic table. We have to survive our own technological adolescence.
That is a powerful, grounding thought. And before you go to sleep tonight, I want you to consider one final provocative idea that flips everything we just talked about on its head.
Okay.
Throughout this entire deep dive, we've made one massive underlying assumption. We assumed that highly advanced Type 3 civilizations would be loud, massive, and highly visible.
Like the Dyson spheres.
Exactly. We assumed they would build giant Dyson spheres that block out the light of stars or re-engineer entire galaxies, leaving massive, undeniable thermodynamic footprints in the cosmos. But what if that entire assumption is a human bias?
How so?
What if that's just our primitive industrial revolution mindset, our obsession with building bigger engines and burning more fuel projecting itself into the future? Paleobiologist Ola Vin suggests a concept called technological minimalism.
Minimalism. Interesting.
What if truly godlike civilizations don't build bigger? What if they build smaller? What if they master quantum scale engineering, maximizing their computational efficiency to the absolute limit, to the point where they leave zero thermodynamic footprint? They wouldn't look like a sprawling, brutalist empire of machines. They would blend in perfectly with the quantum foam of nature. They would look exactly like a pristine, untouched natural universe. You look up at the empty night sky and you feel a deep existential loneliness. But what if this silence isn't emptiness at all? What if it's the ultimate signature of a civilization that finally learned how to live in perfect, quiet balance?